Okay.
We're ready again? Okay, steady rest. So first, a little disclaimer. What we're going to talk about is this one, which I built, but it met my needs for my lathe, and we'll talk in a minute here about why it doesn't fit on this lathe. Okay, so you have to, if you're going to do something like this, you got to think that through a little bit. Okay. So, why do you want one, right? Well, if you're going to turn something that's long and slender, and in my case, I have a friend that wants me to build 1-inch walking sticks for him that are 60 inches long. Okay, so those are going to move in the center as you try to turn them, right? So I needed a steady rest to try to control that. The other thing where you see them used a lot is if somebody has a vase that's here on the headstock, but it's got no tailstock support, or a hollow form, something like that, where it's sticking out here a ways. You'll see them used for that too. Okay. They're also kind of cool. It was fun to build. Maybe you always wanted one. You'll figure out how to use it later. Stuff like that, right? Okay. We do stuff like that. So, what do you need to do in terms of decisions, right? First of all, you got to decide what you want to turn. Okay, we kind of talked about that. And then, what do you have in your shop? If you're going to build it yourself, what do you have in terms of tools, your woodworking skills, your metalworking skills, if you're going to go down that road? Shop space. Is cost a big driver? This looks expensive, but I had the plywood and the oak for all the bases laying around the shop, so I probably have $50 in this. Okay, and probably just a little over half a sheet of plywood. And then you have the ability to draw it up, lay it out, do the work, that kind of thing. How versatile do you need this thing to be? I.e., what's the smallest object you want to turn, and what's the biggest object, right? Because some of the other designs are very limited in size. This, I can get these wheels down to about a ½ inch circle here. And I can get them out to about 15 inches in diameter. Okay, so it's got a lot of capacity here. If I want to go bigger than that, I'm screwed. And I could have done some things different in terms of the way I built it to get a couple more inches of maximum diameter out of it. But I chose to do it the way I did to get more stability in the arms rather than having them hanging on the outside. You need to gather some information first, okay? What's the swing radius of your lathe? Okay, in my case, it's 12 3/8 inches, or 12 3/16. So I built it to fit that. So this center point right here centers on my spindle, okay? I could, and you can kind of see it here,
Definitely not on that.
obviously doesn't line up with this particular lathe because it's got a different swing radius, right? You could lower the two lower arms and bring the upper arm down, but then the radius, you'd be doing something down here, and these would be out of ways. You couldn't do something really small. So you got to get that, okay? And that's important because everything you do when you're building this thing centers around keeping this point on that point, okay? So when you start cutting pieces here, you always have to think about, okay, I'm adding this, I'm subtracting this. I got to keep this point at the same point above the bed all the time, okay? The bed configuration, how you're going to attach to it, what your slot looks like, how big the slot is. I mean, I measured everything on my lathe. There's a machine section underneath here, and if you feel underneath the lathe, you're always going to feel a rough area next to that. You've got to run inside of that. So kind of how are you going to clamp this thing down? Clearance. My lathe, my tailstock is on an extension that just swings open. This one lays down, right? So I had to figure out, okay, where am I going to put this arm so when I try to slide it on the lathe, it clears that piece of tailpiece, that tailpiece that's sticking out here, right? So you have to be able to get that thing to come on and off, right? Real shame to build one and not be able to get it on your lathe.
It just tells you you're recording.
Okay, great.
If you need it to work on multiple lathes, you might need to think about a different design. Probably the simplest thing. So, they come in a lot of different flavors, right? I call this one the traditional circular opening style. Okay, the second one up there. Okay, there are non-opening ones, and when I say opening style, I wanted to be able to get the workpiece on and off without having to remove tailpiece, or the steady rest, okay? So I designed it so it opens. Okay, now I can do anything I want here. Okay. There are non-circular shapes. I'm going to show some pictures in a minute here. There are those with metal arms instead of wooden arms. There are some that have lots of arms. There are some that have no arms. There are some that have strings instead of arms. You got arm tabs with multiple bolts. You got round metal frames. You got metal and wood straight frames, spring-loaded ones. Some manufacturers supply one. I think I see that white one closest to me might be from One Way. Some manufacturers of lathes build steady rests. And then there are some incredibly creative shapes, and who knows what else. I kind of quit looking after that. So here's a few pictures of some of these. The more traditional circular ones up here. A couple of these. You got this one where the wheels move in slots and are just clamped from the back side. Not a lot of versatility there. You can do something pretty small, but you can't do much else, right? There's one with, this guy made one with strings. I don't know if that'd even work. Maybe if you're turning toothpicks.
The guy that demonstrated the trembler
could use that. Yeah, that's a good idea.
He did it with cross strings.
That's a good idea, yeah.
And he used a demo floss.
Is this video available online later?
As long as I don't screw up, yes.
You got the opening style here and an interesting shape. Here's one with what is that? Half a dozen arms.
Yeah.
Obviously, you can't get a small piece in there if you got all 6 of those arms on there.
Seven.
7 arms, whatever. I can't even imagine why you would need all those arms. Okay. He also did it with multiple clamping bolts on each point there.
Overkill?
Maybe. Depends on what he was doing. Here's a guy built one with metal arms, right? And Doug brought one we'll show in a minute here that has metal arms that actually it's on a metal frame, but it's kind of similar to that. Here's the straight frame kind. Really easy to build, and there's another one right there. Just 3 wheels. If you want to change the position of the wheels, you just mount them in a different hole. It's a little bit limited. I looked at this originally because you can get down to something pretty small, but when you start to get to something that's bigger diameter, those wheels, those 2 lower wheels right there, don't allow you to clear the frame. Okay, you just draw a circle in there. They'll get too wide and the workpiece will hit the frame. That's innovative. You still had to cut a circle in the inside there. And I looked at that and thought, why bring 3 pieces together at a joint and then drill bolt holes through the joint? I just don't do that. That doesn't seem like good sense. Here's one where it's a metal frame with pipe, the wheels mounted on pipes. And I couldn't do anything like that because I don't have the metalworking skills and equipment to do that. So, this one is kind of a spring-loaded clamping kind of thing. Again, limited in size. This one's a square one, circle in the center, metal T-track for the arms that have knobs on the back. This one is one of the clamping style, like right there on the table. And then this guy, I think he was just showing off his woodworking skills. That's a masterpiece, but
maybe a little like you.
maybe. He was probably an engineer. So, I looked at this and said, what do I want to turn? And my whole thing was the walking sticks. I have a friend, he wants me to build him 60-inch long walking sticks that have a coupling in the center. So I'll be turning something north of 30 inches each, and they'll be 1 inch in diameter.
How tall is it?
A walking stick, Doug. You've seen hiking sticks.
Walking stick should be at your shoulder.
We don't need to debate walking stick. Or the other thing is tall vases or hollow forms or something like that. And I thought, well, 15 inches is probably good enough for me. As far as limitations, I have a table saw and the drill press, the bandsaw and all that kind of stuff, tools to do this stuff. It did not have metalworking tools. And cost-wise, I had the plywood and the oak laying around my shop. So I probably, with hardware, I have $50, I'd say, into this. So if you got scrap laying around, it's a good use.
What'd you use for your wheels?
The wheels are, I actually got them on Amazon, and they are replacement wheels for your little tag-along suitcase. So those are 45 millimeter. They come with axles and bolts and washers, and I had to add a couple washers to get them to clear the arm just a tad there, so a little metric washer.
They have ball bearings?
They do. Yep, they do have ball bearings. Most people make these use skate wheels, inline skate wheels, which do have an advantage because they're kind of shaped like that, right? So you kind of get that real narrow point running on the wood there. These also have a little bit of a crown to them, so they don't run flat, and they're very soft. They're like 70 durometer. Okay, a lot of skate wheels are hard, and when you put something on here, one thing to remember: blue tape is your friend. Wrap whatever you're turning in blue tape, and less chance of getting a mark. Do that. That's it there. So as far as layout skills, I'm an engineer, as you can tell. And then I have my minimums and maximums defined. Again, measure the lathe 1,000 ways, okay? I figured out how I was going to clamp it. I checked all my clearances. I talked about my tailpiece and all. And originally when I built this thing, this is my clamping block for the underside. Okay. And my lathe actually has a longer snout on it than this one, so I can get this right up to my chuck if I want to, because of that extension there. So this length shouldn't scare anybody away. I know if you've looked at the bottom of your tailpiece or your banjo, it's just got a small clamping device down there. I wanted to clamp this thing on both sides and still be able to slide that all the way up there. Okay. And it's just built out of oak that I laminated and cut to shape. Check my clearances. I only had to worry about one lathe since I'm, not a millionaire.
On your clamping block, you tighten the bolts from above or
I do,
below?
from above.
Is there, you can't.
There's two holes here, and all I did was put T-nuts in the bottom. And you drop it and tighten up. I could have put threaded inserts in there, I guess, but it works. And then, again, I decided out of all those options and the pictures I showed, I decided to just go with the kind of what I call a traditional circular type here. So, and then, of course, this is just a picture of what I built. I showed you how it opens already. This, being an engineer, I had to draw it first. So that's my engineering drawing there. And I do have some copies of that stuff here. I brought 4 or 5 packages here with most of this stuff in it. So if you want to, just grab one. And if they're all gone, just give me an email address and I'll just send it to you.
You can also put it up on the website if you want.
Okay, we can do that too. As an engineer, I can't build anything without doing that first. So.
I was an engineer too, I used napkins.
I do that too, but yeah, I do that too.
I still have, one of the very best things we ever did at Cleveland, I still have the napkin that we drew it out on at lunch one day.
There you go.
Frame.
It works.
Because it saved the company.
And then this is just some details of the clamping block and dimensions and the like I used. And then I was sitting down mentally. I got into one of those loops where I was trying to figure out, okay, how small a piece can I fit in there, right? So I drew my wheels to scale. Now those are wheels I did not use, but that's the kind of the exercise I went through to figure out what my minimum diameter would work. Those I think were 56 millimeter wheels. These are 45, so I can make the hole actually smaller. And then here's how I laid it out on the plywood. I actually was able to tighten it up. So I ended up with about a piece of plywood 48 by 44, I think, left over when it was all said and done. Okay. There's a bill of materials of what's in this one, in terms of all the hardware and lumber and everything, and the tools I gathered together to build it, and then a couple of backups. In my shop, that's my workbench. I was uncomfortable throwing a a piece of plywood on the workbench and then using my router trammel to cut the circles. I didn't want to cut my workbench up, so I built those. There's actually 4 of them, arms that clamp to the workbench, so the plywood lays on there. They're 4 feet long. And then that's the router trammel I built. And I just used a plunge router on it. And a couple of the end of the clamping block in the bottom and the opening. Hardest part on the whole thing was figuring out how to cut all these circles on the hinged end so that it would open, 1, and 2, I didn't have a piece resting on a corner when it was opening, laying open. I didn't want to damage it that way. That's it, there, okay? So, what else did we want to talk about here?
On the designs, the various designs, the ones that were like the 2 verticals, that would seem to work on any kind of lathe because you can adjust everything up and down.
It would, as far as the center point is
Yeah.
concerned, and as long as you got the clamping mechanism
You don't have
worked
the
out.
versatility of size, but you would have the
You
versatility.
you
of up
lose
and
the
down.
versatility of larger size,
Right.
but you can, they're very simple and cheap to do. You go get a couple pieces of angle iron or even wood, and a couple pieces of threaded rod and some nuts, and you can build that easy enough. That's real easy to do. I was initially going to go down that road, but then I decided, no, I want something that does bigger pieces. So
But if you just want to do spindles,
that'd probably work.
yeah.
Yeah, absolutely. So, a couple different designs. Doug brought this one. I think, Doug, you said you got this off Amazon?
Yeah, $100.
Basically the same thing as this. You modified the base system, and it came with some pieces that you could add to the bottom to raise this up and down. So that's one way you could, on a taller lathe, raise the center up. On the thing here, right?
Yeah.
And then there's a couple. Somebody, would you hold up, Mike? Maybe
Actually, that's the maximum. The 2 inches is that's made for a 16-inch.
you could modify the base though to
Yeah.
keep raising it up. Mike, would you raise up one of those? Just hold it up here.
Which one do you want first?
Yeah, they're pretty much the same.
Well, not really. 2-wheel versus 3.
Oh, okay. Anyway, is this one made by One Way? Looks
they
like
both
that.
are.
Looks like that.
Yeah.
That's the one they sell, I think. Probably a multi-million-dollar tool. I don't know. Going from One Way. Basically, all it is you loosen up here, and it moves the wheels. I'm kind of not up. Moves the wheels apart, and then you change the upper wheels same way. Just clamp the things together. It works. Gets a pretty small hole. Doesn't get a real big one.
Right, it has a limited capacity,
Got a
that's why I
limited capacity.
didn't prefer that one. I bought the tool used and built my own base, and it's
Yeah.
adjustable up and down.
Same idea, except 2 wheels, which you're just trying to control whip in the center. It works, one above and below or whatever. Same idea though.
So the 2 wheels ride on the back side of your workpiece. So you have wheels and then workpiece and then tool rest. And you're supporting the back, so
Kinda
it doesn't
pushing.
have to open super wide to support a pretty big piece of wood.
And this doesn't need to be symmetrical, it's just on the back side of the piece.
Right. It just needs to be touching, yeah.
Okay, questions?
So what's 15 inches that you want to turn like a little tree?
Let's say that again.
What's 15 inches that you want to
I
turn
was
like a
thinking,
little
I'm
tree?
thinking like a vase or a hollow form. Something that's tall that
Maybe you have
might
a tree
stick
in the
out.
back that you
Oh, a
want.
tree?
So if
Nothing
you're,
like that.
if you were to do it again, what would you do different?
Good question.
I'm not sure I would do anything different, to tell you the truth. I kind of like what I got here. It seems to work. Setup wise, these things don't need to be jammed into the workpiece. You just bring them up until they just touch, okay? And it'll keep things from moving around. I probably would not use anything with a 2-wheel. I think it's just not versatile enough for what I wanted to do.
Right.
So I would stay with something like this.
When you did the construction with the plywood, did you glue up all the plywood and then just cut it?
No.
Or did you cut those pieces?
I cut 3 rings, okay, with the router. It is really important to cut the outer side before you cut the inner. Seen that screwed up. Okay, you're not cutting the outer if you cut the middle out first. Okay, yeah. I cut the outer, I thought that through.
Why don't you describe the sequence, how you did the plywood? Okay.
So basically, I just, I laid those out like on that drawing I showed up here. Used the router trammel and cut the circles out. And then I used, I think I cut the square out of the corner where the arms were and just ran them through the table saw and got them square. The way I put it together, because there's a lot going on in the middle ring, okay? The arms go through the middle, the hinge over here works. This piece here has got that tab that goes down between the 2 outer ones. I originally thought, oh, I'll glue this thing together. And then I thought, how am I keep all those moving parts in position to do that, right? I thought, that is not achievable, okay? I'm gonna put glue everywhere and it's just gonna be ugly. So what I did is I put when I originally stacked it, I stacked the middle ring on the outside, okay? And I did all my layout on that middle ring because that's really where most of the cuts are. And then I took it over to the bandsaw and sander and everything else, and I carved up the middle ring, put it all back together, and used 10 or 15 rolls of blue tape to hold it in place. Okay? And once I got everything where I wanted it, got all the cuts made inside and out, I got the arms in here, and these are pretty snug. I need to go back and put some wax on these so they slide a little bit better. Put it all together, blue taped it back together, and then you can see I used a few screws to put it all together here. So that's really it. With it blue taped together, I drilled all the holes took it over to the drill press, drilled the holes so they were all straight, and that's kind of at a high level how I put it together. The one thing that I had to pay attention to again was where's the center point in relation to my lathe. So when I added this 3/4 inch piece of plywood on the bottom, I had to make sure that I cut 3/4 of an inch off the circle down here, okay? Off the outer diameter, so that stayed at the same place, or I would have raised it 3/4 of an inch. So really important to always keep that in mind.
And how'd you do that?
I took it over to the bandsaw, lopped it off, and then sanded it flat. Yep. Okay.
So at this point, you have no glue.
There is no glue in it, not at all.
So you
It's
do
all
have the
screwed.
potential over time that it's going to get loose.
Possibly.
With all those screws?
I think he needs more screws.
If it gets loose, I'll put more screws in and tighten them
The
up.
trick at this point is you've got it so well designed with the screw holes, you can put a fine bead of glue in the middle, put your screws back in, and it will never come apart.
I'm not taking all those screws out. If I take all those screws out, I'll screw it up. Somewhere we'll get screwed. There are screws behind this piece here. I mean, that's a pretty big disassembly. So no, I'm not doing that. You want to do it that way? Go ahead.
Hey, you said that was about $50?
In hardware, yeah. Not counting the wood.
Robust has a new steady rest at 600.
Yeah, if you want to buy this, there are guys out there that are making these wood jobs very similar to this. You're looking at $400 to $500 for one of those. And like Doug said, Robust has them. I've seen some of the metal ones go as high as $700, $800.
And they weigh close to 100 pounds.
And they're heavy, yeah. They are heavy. This one's not that heavy. The wheels, like I said, are just luggage wheels. Everything on Amazon. Other questions?
Plus you enjoyed making it.
Yeah, it was a challenge.
So when you're turning a spindle 30 inches long and you want to completely, the diameter maintained the whole time, how do you do that? Do you do that freehand?
I use my calipers and I keep measuring that thing all the way down as I go. And a lot of times when I sand something like that, I'll take a straight piece of wood, wrap sandpaper around that and run that wood a long piece here so that it kind of
walking
sands.
stick, so you're turning to what, like 1 inch of diameter or 7/8?
1 inch.
And where are you getting the connecting pieces and how are you preparing the end of the spindle and how are you fixing them?
I'm actually just, what I'm doing is I have two different kinds of wood, some yew and some maple that I'm laminating together. And then it's going to be big enough that I can hold it in the between centers easy enough. And then I'll cut those pieces off here eventually. And then just turn between the chunky ends here,
Right.
cut them off where I want them.
But then you've got, you're doing 2 30-inch or two, and you have to drill a true hole in the end, and then put your screw connectors in. Where are you getting your screw connectors and how are you fixing
Oh, I
those?
think I've seen them at Rockler and Woodcraft. They have these couplings for canes that are a double-threaded doodad that has an internal thread it's just a metal thing you put in there. And I'm thinking I haven't done it yet, but I'm thinking what I can do is when I'm ready to drill it, I'll have it mounted on one end, and I'll pull the steady rest down here, snug it up so it's not moving around, and once I get the drill centered where I want to go, it's going to be good. I only have to go in, what's that, an inch at the most.
Yeah, right.
It's not very far.
And your friend is doing the handles or you're doing the handles?
He is doing, he carves animal heads and mounts them. So I'll leave him with a hole on the top where he can thread a piece of all thread or a lag type connector in the top and mount his head on top of them.
The other thing to play with is get a hold of some rawhide and do a wrapped leather handle with rawhide.
Handles are not my business. Nice thought, but nah, I ain't going there.
So at 30 inches, how many times do you have to move the steady rest?
Yep. Yeah, keep working the steady rest down because I'm starting with a square section. So I got to figure, how do I get that round, right? So what I'm doing is mounting the piece, and then I can turn off this end where it's held and get that round, put the steady rest on, and just keep working the steady rest out as I get it round.
Question. You said that these were made from 3 sheets of plywood. Why do you have to
Were you not paying attention, Doug?
I was back there, I didn't see.
He was
Yeah.
getting a donut.
No.
He was in the donut box?
No.
Yeah, he was.
Yeah,
Yeah, he was.
Yeah.
yeah, it was.
Oh, yeah, okay.
Yeah.
That makes sense.
Nice work.
Yeah.
Yes.
Really.
Thank you.
Excellent presentation.
Yeah.
Okay. Yeah, so this is the underside clamping block that I built. So it goes in this way, right, on the underside. And it just bolts through. I put T-nuts on the bottom. You could put threaded inserts, whatever. The reason we don't have this mounted today here is because this won't go in here, right? You can't get it up from the underside because of all this cross spacing underneath the bed of the lathe. And that was my original plan with my lathe was, I'm just going to fit this thing up underneath and thread it on. And then I built it and it's like, oh crap, it won't fit, right? So unfortunately this lathe with the
Swing away.
yeah, this swing away, no, this is going to lay down.
Yeah,
right?
yeah. I got it. Is it locked? There we go.
Okay. This has this add-on piece here, so it won't go through the hole. Okay, it would probably fit if that wasn't there. This overlaps the hole just a little bit.
Well, is there a bandsaw here? We can just cut that thing up.
Yeah, I think we'll pass.
Come on,
on
Vern.
that. At any rate, on my lathe, it slips right in that hole there. Yeah. Anyway, it's just I laminated some oak together, and then I cut it to fit. So no big deal. Yeah. And I wanted that length. Because I have that extended snout on my lathe, I can pull things up
So
tight.
your
The
bolt
lathe
holes
can-
are extending past the underside of your,
There are the bolt holes.
oh, I see,
Here, here.
okay, all right.
Okay.
Okay, it's clear as mud now.
Anything else? Okay.
Cool.
If anybody would like to play with one, I just took a broom handle on the white lathe in the back corner, using my homemade steady rest with the 3 wheels. without the steady rest, that piece of wood, that broom handle, which I think is oak or something, will whip by 2 inches or more. So it's impossible to work on it, but you can, I also playing down one end of it a little bit, but feel free to go back and experience it if you'd like.
Is it snugged up right now, Dave? It looks like it. Maybe loosen it up a little bit so you can see the whip, and then you got that one too.
Yeah.
See what steady rest does here. Like I said, you just got to touch it. Okay, you don't need to clamp the thing down tight.
In
But it
fact,
helps if it's round before you put it in.
Ain't gonna work if it's not round. It's gonna be kind of bumpy.
if you do clamp it too tight, you compress the wood fibers in your workpiece, and that compression goes deep. You can't sand out the mark that leaves. I have some urns that have this big circular tire mark around the urn that I can't get out. So don't clamp it too tight.
Well, it's a
And
design
again,
feature.
You're right, yeah.
Again, blue tape
Decorative.
is a nice protectant too, because some wheels, these are real soft and they look black, but they're actually kind of clear. Some wheels will mark them. And I have seen people build them using bearings and thought that's a bad plan.
Yeah.
With a steel bearing there, that's a mark guaranteed. I don't know why you would do that, other than maybe have them laying around in a drawer.
Well, you only did it once, and then you found
Yeah.
out.
And again, these come in different softnesses. A lot of people, I said, use skate wheels, and they run from 70, 72 durometer, which is pretty soft, up to ridiculously hard. These are about 72, I think. And you can actually compress these a little bit with your fingers.
Only the engineers know what a durometer is.
One of those engineering scales, you
So
know.
the softer they are, the less likely they are to mark.
Yes. But again, no matter what I put in, I'm putting blue tape on it. Get it nice and smooth.
So you just keep wrapping blue tape as you go.
Yeah, just change it. Yeah,
It's cheap.
big deal. It is cheap. And once you get, on a piece where you got it round out to the center and you got the biggest whip happens in the center, right? You get this thing mounted out here where you're close to the center, you've taken a lot of that noise out of the system already. It's just not gonna go around anymore. Okay? Cool. Thanks, guys.
So can you explain sort of the process of how you start with a square block and then get to the point that this is actually useful?
What I'm doing,
Just a brief description.
I have this 30-plus inch long square block, okay? And you got a hard mount here and a hard mount here, right? It's not gonna move around there. It's gonna move mostly in the middle, right? So what I'm doing is I'm starting to round it out over here, okay? And then I put the steady rest on. And then I keep walking the steady rest behind me as I cut across.
Until you get to the center or until you get to the other end?
Until I get to the center, and then I can keep going as far as I want.
So you just set up the steady rest, open things up so it's not in the way while you're getting started, and then
Yeah, slide it. You could pull the arms back, set it over on this end, round it out here, pull this thing back so it's over here. Banjo's in the way there.
just keep it wide open in the beginning while things are moving
Yeah,
around.
and then as you've got the steady rest on, just keep working the way across.
So you have to take the banjo off and move it, or how do you get the banjo from one side to the other?
I don't. I work on that side. I can get that right up there, and I can get a tool rest in pretty close right
So
there.
you make your first start.
Over here, before I have the steady rest engaged, because this is fixed on this end, right?
Right.
So round it out a few inches this way, then put the steady rest over here, get the banjo over on this side, and then just keep working everything across this way.
You gotta remember the snout on his is longer, so you can.
Right. This one's, well, actually, you could do it with this one, but my snout sticks out a couple inches farther on my leg there, so I can get it up there pretty tight. Okay.
Cool. Thank you.
Thanks a bunch.
Yeah, very good.